Right, so Hoodie, if you don't know yet, it's an open source framework / library that lets you build data-driven web apps from the front end, basically. So it's like jQuery, but you get a data store. And these apps are offline capable by default, and the whole architecture is offline capable by default, which is why we're so interested in the whole topic. So what I want to talk about is this idea of offline first, but not really a step-by-step guide to building an offline-first app, because that's what John's been doing in his workshop, and that's what his book is about. It's more about the concepts you have to think about, interfaces, experiences, and problems you can encounter when you do this. So, before we get into that, let's talk a bit about how we work. So, how we work is basically, it's science fiction in a way. So we make web apps, or we make native apps. For our case, it doesn't really make a difference. Many native apps are just web views anyway, talking to servers over HTTP. Not important. But we make, and while we make, we imagine those things in their completed, working, usable state. We imagine them in the future. We imagine all the cool people using our stuff and making us rich and famous, or at least internet famous. And there are various ways of imagining this future. So the bigger the organization you're in, the more grand designs they probably have. So Microsoft is a big organization, and they love imagining the future in really elaborate ways. And they regularly release a so-called productivity future vision, like the one I'm going to show for 2011. And while the name sounds as if someone has just pulled 3 human resources buzzwords from a hat, it's actually quite interesting. Let's take a look at this. On like that. So you have super small, very well designed interfaces, and everything's an interface. The car window is an interface. Nothing needs batteries, nothing has a battery indicator or a Wi-Fi signal strength indicator. Everything's immaculate and perfect and well designed. And it's just wrong. It's too smooth. It's not normal enough. It's a choreography of wealth and status somehow, and it's utterly improbable. So, I don't know. Everyone's happy, nothing is broken or smudged, there's infinite Wi-Fi with infinite bandwidth, no batteries run out, there's no traffic, there's no delays, everything's wonderful. And this is from Tobias Revel's lecture on critical design and design fiction, which I highly encourage everyone read because it's fantastic. And because it's so good, I'm stealing some more from it. So you all know the next one. This is a Google Glass promo.
Okay, Glass, record a video.
This is it. We're on in 2 minutes.
Okay, Glass. Hang out with the Flying Club.
Google photos of tiger heads. You ready? You ready?
Right there. Okay, Glass. Take a picture.
That is awesome. Okay, so no idea why they have a creepy guy in a garage with a 10-foot snake, but on the whole, this is marginally better. There's normal stuff in there. There's people playing with dogs or kids or being late to flights, and that kind of happens to people. But in general, the people and the circumstances, most of them are outliers. That doesn't happen to normal people. And as Ravel puts it, it's a classic case of everyone suddenly being an ice sculptor or flying around in balloons. And it's also not normal. It's a fantasy. And as far as goals and dreams to work towards go, it's all a bit weird. But it's also more nuanced than the previous one, because it has some degree of normality. And it's implying something interesting. So people are using Google Glass in places without network communications, you know, in the sky, for example. And unless that first guy in the balloon was flying around in one of Google's new internet balloons, providing Wi-Fi to the guy in the plane and the skydiver, I think we can imply that they want Google Glass to work offline. Because how else would it work, really? Now, let's go back a bit in time. The next video is from 1969, and it's a vision of the 1990s. So I'd just like you to picture that in your mind for a second. The future seen from the 60s, right? You've all seen the movies. Okay, and now consider that this was made by the British Post Office.
Let's take a look at the sort of facilities we can give him. Worldwide communication, of course.
Hello, Bill. This is Henry.
Who? Who did you say?
Henry. I'm calling from London.
Gee, that's a pleasant surprise. How are things in your part of the world?
Well, it's a dark, wet morning here. I suppose you've been basking in the sun all day.
And, when we want it, view phone, in colour, using digital transmission by pulse code modulation right into the customer's premises.
Well, let's have a look at you, Bill.
Right, Henry, picture coming up. Gee, it's good to see you, Henry. You're certainly looking fit.
How's Betty, Bill?
She's right here now. Come over here, Betty, and say hello to Henry.
Hello, Henry. Long time no see.
But we can do much more than that. Library services, transmission of documents, share prices, bank statements. Let's take a look at the subscriber's terminal unit. To make a call, we take our service card. The code will be scanned electronically and establishes the caller's identity for charging the call. As she keys, the digits appear on her viewphone screen. Suppose she makes an error, she can clear and start again.
Right. And then a ship comes into the harbor. Okay. But, you know, that seems rather normal. So, you know, people aren't wearing futuristic clothing, driving futuristic cars, doing extraordinary things, sitting at transparent desks with flashy lights or something. We see a normal man at a normal desk, at a normal office, and there's some funky electronics standing on it, but apart from that, it's really normal. And the first thing that happens is it doesn't work properly. So here's the British Post Office introducing this new technology. The first thing that happens is the guy at the other end can't understand what he's saying, which is utterly normal. And the weather's bad, and it's London, and it's normal. And listen, suppose she makes an error. People don't make mistakes in Microsoft's future productivity vision or whatever it was called. And nobody in the Glass video goes, Glass, did you hear me? So, yeah, normal. And the topics, you know, leases, bank statements, mortgages, normal, normal, normal. And it's mundane, and it's wonky, and it's a bit boring, but it's everyday life. So, for every miraculous iPad, there are countless partly broken realities. Wi-Fi passwords, connectivity, battery life, privacy, and compatibility, amongst others. The real skill of creating a compelling and engaging view of the future lies not in designing the glossy bits, but in seeing beyond the gloss to the truths behind it. So, why am I telling you all this? Well, basically because we aren't normal. So, we work in the tech industry in super wealthy countries, and we're just not normal. And the circumstances in which we work in aren't normal, and they usually bear little relationship to how and where our products will actually be used. So we build from behind shiny Macs with full-size keyboards in well-equipped offices with great connections, but the target environments for the stuff we make are often radically diverse and different. So we have the best tools and the best infrastructure, and of course that informs our mindset. It kind of shapes the way we think and how we do things. But what you really should be doing, unless you have a super specific elite audience you know really well, you want to build for a normal world. And the normal world with all the normal people in it, with average budgets and average resources and average attention spans, that world, from our perspective, is overwhelmingly mobile. Phones are mobile, tablets are mobile, this thing is mobile. So I was sitting in a burger joint in Bondi Beach 2 weeks ago, and there were two completely normal university students with a little Lenovo laptops, and they had these 3G USB sticks plugged in and were typing away at stuff. And that's a mobile device. They'll be moving around, they'll be switching connections and losing them and running into battery trouble, just like people with smartphones. So mobile is normal. And normality is imperfect, and especially the web. We've heard this yesterday. The web is imperfect, and the experience you're building, it's going to break, I guarantee it. It's also imperfect, and it's imperfect in ways you can't influence, mainly connection speed and reliability. But what we can do now is build experiences to accommodate this normal reality. Experiences that go beyond your apps just, breaking, showing empty views, becoming unresponsive, losing data, making people nervous with error messages. You can now build your apps in ways that acknowledge the fact that the web is imperfect in these ways, that the connections are dodgy, and you can provide good experiences regardless. Because offline is not an error. Offline is a fact of mobile life. So, as an analogy, as John just said, where mobile first is a design strategy to cope with all the unknowable device sizes and things people may be looking at your site with, like, fridges and televisions and stuff. Offline first is a design strategy to help cope with the unknowable circumstances and connection states your users may find themselves in, because we know nothing about them, and we can't take anything for granted. So offline first is simply an acknowledgement that this lack of certainty that we have about our users extends a little bit further than we previously thought. So it's just another form of progressive enhancement, really. We assume that offline is the default state and connectivity is a bonus. We treat the network as a potential enhancement. And in this case, progressive enhancement is the preferred strategy because doing it the other way around, building your app first and then trying to make it offline, is a recipe for disaster because the architecture is quite different from what you're used to. So before we continue, I'm going to show you offline first architecture really quickly. So what needs to be offline at a very basic level for your app? Well, the app itself would be nice. You can just rely on people to still have it in a tab open somewhere when they drive into a tunnel with a train, but you can use app cache or service worker to make it persistent. You can use a native wrapper or PhoneGap or Node WebKit, or you can just make a native app to keep your app and its assets persistent on the client side. And the other part, the really important part really, is that the data has to be there as well, regardless of the connection. So the app must handle data in a way that doesn't require a constant connection. So let's see how Hoodie does this. So here's how Hoodie does syncing and offline and everything, really. So you have a front end and a back end, and in the front end you've got your app. And what your app does, it only ever talks to the Hoodie API. Only that. It never talks to the local browser storage, it never talks to server-side code, it never talks to server-side databases. If it wants to do something, it talks to the Hoodie Store API, because the Store API talks to local storage, or you can replace that with whatever you like, PouchDB, local forage, whatever you like to store stuff in. And that's how that works. And that by itself is enough for an application, really. Do you even need to store anything on your server? Do you need to store credentials, or even less than credentials? You might not. But let's assume you need a server. What we do then is we have Hoodie sync all the content from local storage into a CouchDB over REST API. And we can do this because in Hoodie, every user has a small private database that only they can access. And that makes it really easy for us to decide what we're going to sync, all of it, because it's your personal data and it should be on your device. And behind that is basically the backend. So the Hoodie core and plugins you may want to write in Node.js. And how this then works is, assume you want to send a direct message. So in your app, you create a direct message object, and it gets a recipient, and you tell Hoodie, a plugin you may have written that might be called Hoodie Direct Message, to go and take that, puts it in local storage, and as soon as it can, it'll sync it over into the CouchDB. When that happens, an event gets emitted, and your direct message plugin in the backend can say, oh, look, a new direct message, I probably have to do something. And it will then go and take the direct message, put it in the recipient's private database. From there, it gets synced into the recipient's browser whenever possible. And it'll create a little confirmation object, which it will put in the sender's private database. And from there, it'll get synced back whenever it can, emit another event, and then you can update the UI. So we never have any elements talk directly to each other. They only leave each other messages and tasks, like passive-aggressive roommates, really. It's all very loosely coupled and event-based, which means that it can be interrupted at any stage without breaking. So messages and tasks will be delivered and acted upon whenever possible. So it's designed for eventual consistency. So the nice thing is, in most cases, when you're actually doing stuff in the web app and making things, the front end doesn't really care whether the back end is actually there or not. It will hang on to your data, sync whenever it can, and if your UI allows it, users can just keep working without interruption. So if you want true offline capability, your app can't try to talk to the server directly, only through a syncing engine. And you always want to keep a local copy in browser storage. And sync is hard, really. Don't even think about implementing this yourself. There's just so much to get wrong. So we rely on CouchDB for this, because it's a database that replicates, which is exactly what we want for syncing. But there's other technologies, and quite a lot actually, that you could use CouchDB, you could use remote storage, I/O. There's even Git for JavaScript. So there are syncing engines. There's a choice. Remember, whatever you do, don't do it yourself, because sync really is the keystone of offline first. So getting into the offline mindset requires only one key realization. When you leave the world of timely, reliable communication, the local database, and not the servers, must be the gateway for all persistent changes in application state. So how do you make this offline magic work then? Well, storing something in the Hoodie store is as simple as calling Hoodie store add and giving it a type and an object. It's fairly mundane. Want to sign up a new user? Hoodie account sign up. Username and password. Also quite boring. Send an email, Hoodie email.send, and you give it an object with an email. But wait, I mean, how do I offline? Where's the offline? That's it. It's not a feature you have to invoke, it's the architecture. Everything is offline by default. So as long as you get into your head that you have to listen for events, when you want to update your UI, you're basically set. So let's just see that in action. So I'm going to make a new Hoodie app, Hoodie new web directions. And just cd in there and do Hoodie start. That bit of admin stuff. And that opens your browser. And that's a default app, and it's a really crappy to-do app, basically, because you can't even check off the to-dos, but you can add to-dos, which is cool. So what happens in the background when you press enter on that text field is basically only Hoodie store add. You give it a type, and you give it an object. And when I do that, it gets put into the local database, an event gets emitted, and I can update the UI. So that's cool. Let's open that tab again in another browser and see how syncing works. So for syncing to work, I need to be actually signed in. So right now, this was all without a user. Now I'm going to sign up. So the Hoodie account, sign up, just some test credentials, super safe. And I've got a user, and data gets synced to the server. And just to check it, we can check the username. Cool, works. Now we sign in on the other one. And immediately, everything gets synced back from the server. If we add something in one tab, it'll go to the server, and then it'll be synced back to all instances of the local database in both directions. And in the background, you're still only doing the exact same thing you were doing before. Hoodie store add, give it a type, give it an object, and that's just going to work. Because the underlying architecture is that's just how it works. When you type your code correctly. There you go. Right. So now let's do something interesting and turn off the server. Just make it bigger to make it more spectacular. Right, server off. And we can still add stuff. But nothing happens. So it doesn't get synced because it can't. I mean, the server's not there. Or the client's in an airplane or something. Right, turn the server back on. I'm not refreshing or anything. And bling, everything's there. It just works. Amazing. Sweet. So now what? So we felt like we solved the technical aspects for our purposes, and we were wondering, okay, what opportunities does this give us exactly? What can we do with it? Which problems can we solve? And we thought, well, let's ask other people. So Gregor from the team, he went on an Africa hack trip through Kenya, Uganda, Rwanda, and Tanzania. And he met a lot of people with really interesting offline problems. And I wrote a blog post about this whole thing, which got quite a bit of traction and a lot of nice responses on Twitter, which I'm very happy about. I wrote a list apart article, as John mentioned. We held an offline first workshop at Mozfest in London with about 40 people. And we held another one in Berlin a bit later. And as we started asking developers from all over the world about these issues, I was surprised at how many suddenly, opened up about their offline troubles. It was a bit like having, offliners anonymous in a way. So they realized they'd had problems in the past with this, but they'd never spoken to anyone about it because there was no real language for it, and there was no understanding that it was a thing. And most people battled it out alone and reinvented the wheel or gave up or put it off. But all of them secretly wished they could have just, gone somewhere for advice. And people in these workshops had really interesting and specific problems, ranging from, and I quote, runkeeper for fish, for anglers in the Norwegian wilderness, to keep track of what you're catching, and to several people who were trying to build really robust point-of-sale systems for places with bad connectivity and limited resources, where you can't sell the same thing twice, but the devices can't talk to each other. So interesting stuff. But we identified some central themes. So what annoyed people most by far, they weren't able to trust their applications to do the right thing when the connection got dodgy. You can summarize this with the following user story. As a mobile app user, I want to be sure that the data I need is actually there when I need it. And this is so fundamental, I suppose it just gets forgotten most of the time. Of course, everyone wants this, right? But it used to be a painful problem to solve. And it was easier to just, throw an error, show an error message, and let people blame it on their providers. But in some cases, you can't do that. So here's an advert from the German railway. And it's for their new booking and ticketing app, which you can apparently use at any time, even when free soloing in the Alps. Because in the future, everyone's into extreme sports and ice carving. Meanwhile, in the real world, here's a guy tweeting to the railway company saying, Dear railway company, how can it be that your app takes 2 full minutes to start up when the connection is bad? My tickets are in there. So they thought of this. So it works in airplane mode. You can get your ticket when there's no connection, but you can't get your ticket when there's a very bad connection because it will keep trying to get your ticket. So when you're on an actual high-speed train where exactly this thing happens all of the time, you can't get your ticket while the ticket inspector is breathing down your neck. So that's a bad experience. What people always do, I think a lot, is taking screenshots of their apps because they can't trust them to retain their state. I do this all the time when I'm traveling. Who does this? Who takes screenshots? Yes, awesome. Lots of people do this. Okay, I don't have to talk about it anymore. But you do this because you're afraid that the data you have in the view will just vanish the next time you open the app, so stuff like this happens. All of these were full of data before I took the screenshots, just moments before, but then I made a fatal mistake, like, putting my phone in my pocket or switching apps. And then the apps go and say, oh, wait, I got restarted, I'll fetch new data. And they see that they can't fetch new data. But before they did that, they threw everything else away. And then you're stuck with nothing. And even if the app stores stuff locally, how clear is this? How clear is it whether and which data is there and will continue to be there and under which circumstances? So some of those are stored offline. I don't know which. There's no design convention to tell me, yep, you can trust me, this thing is always going to be here. So if you manage to solve this problem, it's a great opportunity to make more trustworthy and more reliable apps. Another problem. Apps are designed to be online all the time, even if there's absolutely no intrinsic requirement to do so. So, as a mobile app user, when I'm offline, I want to be able to use features that don't require a connection. This is especially relevant for, productivity tools. So if you're only adding data yourself, why doesn't this just work, You should be able to add a meeting and mark a task as done or write a message, create things. Just store it now, sync it whenever it's possible, but don't get in the way of people actually making stuff or getting things done. And again, it's an opportunity. You can have more useful and more usable apps. And it's directly linked to the next one, which is my data isn't with me. So as a mobile app user, I want to have my personal data on my device at all times. And it's my personal data. Why shouldn't it be on my device? I might need it, and you don't know when. Plus, in most syncing scenarios, I'm the authority over my data, so just let me have a local copy. And granted, this can get problematic if you have really highly collaborative applications, but if you have a use case where your data is fairly well isolated, you can easily do this. And again, the opportunity is always accessible personal data. Another favorite of mine, that apps frequently require advanced planning to still be useful when they go offline. They're not smart about what they do. So as a mobile app user, I want apps to preempt my needs in a sensible manner. Because you don't know what I might need in advance, and I don't either. But the app can make a sensible decision about this in some cases. So think about this. Once out of bed, internet and apps are used almost constantly, peaking during the daily commute with 70% usage. So people use their apps most when they're traveling, when our connection's worst, when they're traveling. It's a great opportunity. So as an example, RSS readers. With a non-smart RSS reader, you're always caught in situations where you're in the tube with a day-old article or something, because you explicitly had to tell the thing to go and get new ones. But what else would you want in an RSS reader except the newest stuff? So it would make sense if the app preemptively updated your feeds in case you went offline, because that's when you want to read stuff. And obviously important data should probably be stored locally. So Dropbox is good in this regard. If you fave things in the Dropbox app, it'll know, this is probably important to the user, I'll keep it around, and it'll stay on your phone forever. Now I suppose most of you are from Australia, so maybe you didn't have this problem at this conference, but if you travel a lot, you'd probably want this. Smart offline maps. Wouldn't that be nice? So you can have offline maps, but you have to know in advance. You have to buy an app, and you have to download the files for the country you're going to, or you can invoke this bizarre ritual to get Google Maps to cache your surroundings. I don't know if you know this. So you go into the search box, you enter OK Maps, you press search, it will preload the map, and it even has a funky loading animation. The on-screen map area has been cached. Fantastic. It's obviously experimental and hacky, but it's quite useful. But you could go further. Now, Maps knows where you live, right? So imagine if it would preemptively download your surroundings as soon as you go overseas and you're on Wi-Fi. That'd be cool. But on the other hand, this nicely demonstrates some of the problems when you're doing offline. You need new UI elements, plus you need to answer some pressing questions like, how long will the cached map be around? Does it get flushed at some point? Can I remove it when my phone gets full? Can I cache it at some other time? Or can I cache more than one at one time, or do they overwrite each other? Is there some sort of limit? In short, how does it work, and can I trust it? But if you do manage to communicate this, you can have smart apps that preempt user needs. But as we saw, it can get quite tricky. So let's talk about the challenges as well. So it's obvious that there are a number of new things you could be doing, and that these new things require new interfaces, and in some parts, even a new design language, because you have to communicate stuff you didn't have to communicate before. So, save versus sync. When is it saved? When is it synced? What's the difference? Is it just scheduled for sync, or has it already synced? Is it out of date? Is it conflicting? There's all sorts of new states things can be in, and we might have to communicate this somehow. And connection states, too. We all know the spinner is a lie. It means a lot of things, but in the end, all it means is, I'm not ready, and it's too complicated to explain why. But you want to reassure your users, right? We need to find a good language for this. So if your app now behaves differently depending on whether it's connected or not, you probably have to make this clear somehow. So Threema does this by displaying a connectivity stripe at the top. Don't know if you can see it. So if it's not connected, it's red. If it's connecting, it's yellow. And if it's connected, it's green. And it's always there. And the app teaches you what that means and what consequences that has before you use it the first time. That's one way of doing it. But you could just as well selectively disable or hide or rephrase features. So imagine a save button that knows whether it's connected to the server or not. That could turn into a save and sync later button when it's not. Or you could just let users work on as normal and then inform them about what happened afterwards and say, yep, we saved it locally because we're offline and we're syncing it later. But there's loads of ways to solve this problem. You can be super secretive and just get it done in the background, or you can be really verbose, informing users about everything before, during, and after they've done something. And it depends on your use case and your target audience and how crucial the data is to them. One of the really nasty problems is informing users about sync outcomes in detail. Not whether they succeeded or not, but how and possibly why data has changed in their browser, possibly even in the view they're currently looking at. Because that's one of the things that happens when you sync stuff. And that's probably one of the hardest problems. So here's a really simple example. A chat between A and B. A says hi, B says yo, A wants to meet on Thursday, B says yep, I'm free, and then A notices, wait, I meant Tuesday. Now imagine B's second message, sure I'm free, was written on while he was offline, or they were offline, on a train, in a tunnel or something. So you'd get this situation. But you've got offline first architecture, so everything's cool. The train comes out of the tunnel, everything syncs back up again, A receives B missing message. The big question is, where do you put it? So the first thing you probably want to do is put it where it belongs, in the chronological order, in the correct place, which makes sense in a threaded context, because order carries meaning. But that might mean the message appears somewhere way up there, out of the user's current view. So there's a new UI challenge in itself. Or you could do what iMessage sometimes seems to do, display it in the flow according to the time it arrives at. Now this solves the problem of visibility because it guarantees it'll actually be seen, but it has the potential to change meaning because message order is meaningful. And this is only text-based, one-dimensional data. What do you do with deleted items or things that can't be organized in lists? Objects that aren't immutable but can change parts of their state, things in 3D space, crazy stuff might happen in the next few years. There's a lot of potential for complexity here, and it's something to be aware of. So it's not a magic bullet that'll just solve all your problems. And I'm beginning to think that the technical aspect is actually simpler to solve than the interface and experience aspect. But there are a couple of additional advantages too. So let's talk about those. Performance. We put stuff in CDNs to move it closer to the user, but the closest thing to me right now is this in my pocket. Move your stuff here. That's zero latency for me. That's the best possible, fastest experience I can have if all your assets are on my phone already. Offline capable apps are really robust. They protect from service interruptions. So interestingly, we hadn't even thought of this beforehand. We have a fairly large service running on Hoodie, and we had to briefly take it down for maintenance and experimentation and things. And we found that most people using the app at the very moment we took it down didn't even notice, because it just keeps working. It doesn't matter if your app can't reach the server because the user's in the subway or because the server is down. It'll still work. Server down, I don't care. Also, if you want to swap the backend out, you can. They're swappable commodities now. As long as they speak the same API, you just exchange them, move them around. It's fairly simple. And as a whole, it's just a better experience. Apps don't lose data, they're more trustworthy, apps are more usable and useful, and they cause less frustration. And you can do awesome stuff like, you're only saving to the local store. You can save every single keystroke if you want, and then just sync every couple of seconds, which is really cool. You might not even need a save button anymore. And you can't do that when you're talking directly to the server. You can't make a request for every single keystroke. That's just stupid. So there's a lot to be gained from offline first architecture that's not completely obvious at first glance. And you can ask yourself, do I even need my users' data on my server? So the more you think about syncing and data, you might come to the realization that you don't actually have to or even want to store your users' data on your servers. This could do wonders for scalability and privacy concerns, and it might even be a business benefit for what you're doing. So you may be looking at all this and thinking, it seems like a lot of work for a really specific use case. And networks are getting better and denser all the time, so why really bother? So think of your everyday mobile experience, even in the wealthiest, well-connected first world cities we run around in, and then your mobile experience in the countryside while traveling in other countries, and then realize that global mobile traffic is on this kind of growth curve, and we're in the middle. It's going to get a lot worse. And there'll be more and more active smartphones, cheapest ones are selling best, and each subscriber's data use is expected to multiply over the coming years. And people are already relatively unhappy. So yes, 51% of people are really satisfied with their operator's network. 3 are outright dissatisfied, but that leaves almost half in a position where their satisfaction could easily be improved. So half of everyone already has problems. And admittedly, carriers are pushing new transmission technologies like crazy, but they'll never reach full practical coverage. So the graph shows population coverage. So they want 85% HSPA coverage by 2017. But that just means that, coverage, it doesn't mean real connectivity. And even if your city is blanketed in cell phone towers, it doesn't mean you'll always be in that city. And if you are, there'll still be subways and dense buildings and other dark spots, and there'll be travel and international roaming charges, uncovered countrysides, boats, planes, balloons, overpopulated radio spectrum. And plus, if there's new technologies, people need new devices to take advantage of it too. So I live in the capital of one of the most developed nations on Earth. I have a 600 euro phone, and I frequently only get unresponsive edge connections or none at all. And that's before I even go into the countryside or get on a train or something. So don't just wait it out and hope it'll solve itself, because that doesn't help users. And networks aren't the only thing. Apps and web apps are really popular, and they're competing with old-school native desktop applications that save to disk in many fields. They can iterate quicker, and they can cover more platforms with less effort. And people are moving their stuff to the web and to web services in droves, and it's only going to increase. Because any application that can be written in JavaScript will eventually be written in JavaScript. And today, we're collaboratively editing and syncing text, plain text, between multiple devices and stuff, and next year it might be something more different and complicated. Graphics, music, 3D things, tables of data, anything really. And if it's in the browser, it's going to be used on mobile, and it's going to be offline at some point. And the browser really is the place to be. Because at some point recently, the browser transformed from being an awesome interactive document viewer into being the world's most advanced, widely distributed application runtime. It's a very attractive platform for developers for many reasons, and as web apps gain complexity, and also mobile native app usage increases further, users will simply expect the apps to be as mature and as solid as the ones they had on their hard drives. And waiting for more cell phone towers to be built isn't going to help them. So, in closing, we can't keep building apps with a desktop mindset of permanent fast connectivity, where a temporary disconnection or a slow service is regarded as a problem and communicated as an error. We can and should do better. So this whole offline first thing, it's early days and there's a lot to talk and think about, and nobody really knows what they're doing, especially in the UI front. There are still many technical challenges, so we feel like we've kind of solved what we want to do with data, but you might disagree. And when it comes to apps, service worker is still far from ready, app cache is a little bit painful. That could all be a lot better. But more importantly, I think we need a design language for offline first. We need to be able to communicate these things effectively to the people who use our apps. And there aren't really any comprehensive UI pattern libraries or established design metaphors for save versus sync and all the other states we have. And we need more awareness that this is a real thing. Especially awareness of the problems, and especially the problems that we ourselves are not exposed to. And more awareness of the technical possibilities, and more awareness of the opportunities of embracing this paradigm. So what we did is, we started offlinefirst.org to bring people together on this, and we've got some discussions going on GitHub, we hold workshops, we travel around, talk to people, and we started collecting other resources and projects that aim to fix this, as well as people's feedback to ours. And I'd like to invite you to add your own ideas and issues to this, so please join in. And also, if you do want to try out offline first, don't panic, use Hoodie. Please come to me if you want to know more or have some of our awesome hoodie stickers. And that's it. Thank you very much.